Here is your lecture continued with problem 2a. So you see fractions here, they have the same common denominator. We can get rid of those if our first step here is to multiply both sides by 5. So when you do that, it will look like 5 times 3/5 y 5 times 105 y squared. 5 divided by 5 makes 1, so we're left with 3y equals y squared. In order to apply the zero product property, we have to get 0 on one of these sides. So maybe we will subtract 3y here, subtract 3y here. This thing is going to make 0. Now, here's something we can factor. We can go through with the box and diamonds, or you can see that you can just factor out a y, undistribute a y. But for practice sake, let's draw it out. If you see the shortcuts, you're welcome to take it. Okay. Oops. Okay, so it doesn't go there because we have no third term, right? So then really that's 0y. When we write it out, 0y squared. This is where your 3y should go. So in order to multiply up to 0, that has to be like that. And if we needed to add up to 3y, it must look like this. And then you see that you get this stuff on the top. So in factored form, it looks like y times 1 minus 2 equals 0. I'll shrink this down to get a bit more space. So then we can solve this thing. From here, it's like what we did yesterday. Y equals 0. For this first part, we're done. Y minus 3 equals 0. Add 3 to both sides. Y equals 3. That's our second answer. For this one, I think it's worth checking. Check. For our first answer, y equals 0. Does 3/5 times 0 equal 1/5 times 0 squared? 0 equals 0. Anything times 0 is 0. For the second one, for y equals 3, let's see what happens here. 3/5 times 3. Let's see if that equals 1/5 times 3 squared. Three times 3 on the top is 9/5 equals 1/5 times 3 squared is 9. Yep, 9/5 equals 9/5. So we know it worked. So this problem here illustrates that, okay, once we have this, don't be too intimidated. Since they have a common denominator, we can get rid of those, turning it to something we do know how to factor. And when things look like no constant term, no third term, this is how we factor it. And then this stuff is what we were doing yesterday to solve. Here's 2b. This one emphasizes those steps from earlier. Notice right now we can't factor this just yet, or solve it, or apply the zero product property. We have to move things over. How did I get here? I added 8x to both sides. Maybe now I'll demonstrate the shortcut. So here we notice that 2 and 8, they have something in common. They have 4 in common. We can unfactor that. Not unfactor, undistribute that. And for this one, we see that, these two terms, they have x in common, so let's take that out. Well, that's another way you can factor without having to draw out the diamond in the box. But if you drew the diamond in the box, you would have gotten the same answer. Solving, like yesterday. 4x equals 0, divide by 4, x has to equal 0. On this side, x plus 2 equals 0. So x has to equal -2. And we can check using the original problem. Four times 0 squared equals -8 times 0. 0 equals 0. Nice. 4 times -2 squared must equal -8 times -2. -2 squared is 4. -8 times -2 is +16, which is true. Here are your next two problems. One with those fractions in it. Another one, well, looks like we don't have to do anything special for this particular one. It's just factoring. So we look at, do they have anything in common? Yes, they do. They have n in common. So we can move that to the outside. And so if you were to FOIL like that, notice you'd go this way. You get your original thing. Then we can solve. I'd for this to be in this color. My checking color was the other one. So then we can solve both of these things. We get, for this one, n equals 0. Nice, we're done with that side. -5 equals 0. +5 plus 5. And has to equal, 5. Now we can check in this color. There's no harm in checking over your answers. Like on the test, if you have some time left over, it's a nice reassurance. 25 minus 25, 0 equals 0. Nice. Alright, back here. We see fractions. We don't here. So multiply both sides by 3. The result will be 4 minus y. 3 times 0, 0. The Gaussian scale is how to factor it. We can notice they have y in common. So it'll look like this. Minus 1, because y times -1 gets you negative y, or minus y. Notice that if we drew the box like this, we would have gotten the same stuff. No need for that. So maybe I'll shrink that off to the side. solve. Y equals 0 from this, or y minus 1 equals 0. A little bit more work. Solve for y, get y by itself. Divide by 4, divide by 4. Y equals 1, 4. We can go through checking, but we still have a couple more problems, so I'm going to skip that. You can do that and confirm, practice your fraction arithmetic. Some more complicated ones. Now we have 3 terms. Already, I noticed that these things are probably perfect squares. If you see that shortcut, try to apply it. If not, go back to your box and diamond. E squared 144, because that's the third term, x multiplied together. Middle term goes down here. Negative 12a, negative 12a. Negative 12a, negative 12a. So it looks like this. You could also rewrite this, a minus 12 squared. And so when we solve, we just have to solve this one. We only got one answer here, because these two things are the same. We'll go through the checking step. So 12 squared minus 24 times 12 plus 144. That should equal 0. 144, this should be 288. So 240 and 48. Yep. So what I did was 24 times 10 plus 2 in my head. Add these two things together. 288, that's positive. Take away 288 gives us 0. To the side, 0 equals 0. To this side, draw our box and diamond. Huge box and diamond. 100m squared, 20m, 10 and 10. Let's try 2 instead. 2m, 2m, 5, 5. Yep, that's it. 2m plus 5 squared equals 0. We just have one thing to solve. M equals 5, divide by 2, divide by 2, m equals 5 over 2. I'll skip the stepping, skip the checking. Here's the first word problem. A number decreased by 5 is multiplied by the same number increased by 5. Product is 56. So we have to translate this part and this part into words. A number decreased by 5 multiplied by the same number increased by 5 equals 56. Find the number. So we may think, okay, at this point we can like set this thing equal 56 and this thing equal to 56, right? That's not the way to go, because there isn't a 56 property, right? There's 56 property, product property. There's only 0 being the special number. So for this one, we have to multiply this thing out. No x's, minus 25 equals 56. So that equals 81. So from here, just take the square root of both sides. X equals 9, or it could be negative 9. The square of a number is equal to 14 times that number, decreased by 49. Find the number. Again, so the square of a number is equal to 14 times the number decreased by 49. Find the number. So close. Let's move these things over there with some subtraction. X squared minus 14x plus 49 equals 0. I notice it's a perfect square. So if you know how to do that, you can take that shortcut. And if not, then we'll draw our box and diamond. Squared, 49, 49x squared, negative 14x. So it's negative 7x, negative 7x, negative 7x, negative 7x. So we get this thing. We solve. X equals 7. That's all for the fundamentals. The enriched portion has this word problem. And just to put it into context, you can draw a little picture. So there's your boat. Or there's your axes, there's your boat. And then you shoot your flare, that'll go like this. And it'll fall back down. Okay. There's the little person. Okay. So when we use this equation, the initial velocity, that's your v. And when you hit the ground, okay, that's when x equals 0. Instead of x, we have h and t as our independent dependent variables. So to solve this problem, we make a substitution, 160t minus 16t squared. This thing does look like something we can factor. In this case, we won't draw our box and diamond. We'll take a shortcut and factor 16t 10 minus t squared. Oops, no t here, like that. Then we can find out our answers. From here, 16t equals 0, so t has to equal 0. From here, 10 minus t equals 0. Add t to both sides. 10 equals t. Okay, so what does this mean? This means that it was first at the ground at this point. t equals 0. That's your start. Of course, it's at the ground. We haven't fired it yet. Then after a certain amount, after 10 seconds, that's when it'll reach the ground. That's your other x-intercept. That's often why you have two, because you start and then you stop. You start at the ground, it goes arc, and then it comes back to the ground. So in this case, it doesn't make sense. Flare is not fired. So really, it's how many seconds it will take, so the answer here is 10 seconds. Second part, when will the flare be 336 feet off the ground? Well, for this one, now we gotta look at its h. We have a different h value. So wherever, maybe it's like here. Let's say this is 336. Okay, and then we're wondering, okay, so what time is this? And what time is this? Now we set our h equal to 336. 336 equals, same equation, 160 t squared minus 16t. Oops, 16t like that. If you're curious, this part is like 16 feet per second. That's your gravity, which you'll study in physics, which is why I chose this problem, because for those thinking about taking physics, this is what it's going to be like. So we got a factor. How do we want to do that? Let's do negative 16t plus 160t minus 336 equals 0. I think we can take out 4. Can we take out 16? I have to check. I don't know if 16 is a multiple of 336. Grab calculator. Oh, it does. Okay, so we can take out 16 right off the bat. That leaves t squared plus 10t, and this one leaves us with 21 left over. 16 is a multiple of 336. Now we can solve this middle thing. As you can imagine, we can divide both sides by negative 16. And we can solve the middle part. I think these ones end up being 7 and 3. So I did the time in my head. Two numbers that multiply to 21 but add up to 10. So t equals 3 seconds and 7 seconds for the flare to be at 336 feet off the ground. As its first instance here of 3, then we learned that that was 7. And that's all for today.